All right, let's take a look at this second example here. All right, the obvious hang up for students on this are twofold. Again, normally we're giving you all the resistances, but in this case, we've not given you the resistance of R1. But in order to solve it, we have to give you another piece of information. And it's this current here. Secondary to this problem is you have to realize or recognize where you put that current. The second hang up is this particular example was drawn intentionally in a less visually appealing manner. And it makes it harder to decipher what's going on. So I'm going to end up redrawing this for you that in a manner that doesn't change the circuit, but you can see it easier. And that's the second hang up there. That was the intention for this. So again, let's just take a look at RT here. Let's explain this thing, how we are going to attack this thing. It's R1 plus. Again, it doesn't matter how you want to go through this circuit current-wise, it's all going through R1. So R1 is in series with everything else. Now, if you don't recognize the balance of what I'm going to write here in this brief equation, when I redraw this, this should make more sense. So right now, we've got R3 is in parallel with R4, and those two are again in parallel with the sum of R2 and R5. So this whole thing is a bit of a combination circuit unto itself. So I have to do a bracket here because we've got to do this parallel portion before we ever add it to R1. So I'm going to say R3, and again, it's just in parallel with R4. Now, those two also are in parallel, but they're in parallel with the sum of R2 plus R5. So I'm just going to give it a different bracket. R2 plus R5, close that bracket, close the outer bracket. That's what that is. Okay, that's what this little explanation is there for. That's how we're going to attack these. So we know we have to add these two first, and then that will be an equivalent resistance. So that equivalent resistance is in parallel with R4 and R3. You work out the parallel resistance calculation for that. And if we had R1, we would just add it to R1 and we would get RT. But that's how we were going to attack it, or we would attack it, calculating RT. And that's how you want to look at the circuit, because it's laid out just like that. So let's just quickly throw in our values here. 12 volt total. Now 4 amps. Hopefully people recognize that that is IT. And also, like previous examples, all the currents going through R1. So if we know IT, we also know I1. You're going to have to know that sooner or later. Now we don't know the resistance of R1. R2, let's make sure we get them right, is 4 ohms. R3 is 4 ohms. R4 is 8 ohms. And R5 is 4 ohms. So this is all we know, and I've thrown that in there as well because it's not a calculation. So let me redraw this. All right, so I'm going to grab another piece of paper, and okay, we've got R1, and if I made this easier, I'm just going to keep this here. I'll put it back up in full view later. So I'm just going to do this. That connects there. That's R3. Pardon my penmanship. I'm working around a tripod arm. You can't see it, but it's here. Or a tripod leg. R4. Now I'm going to do something here. R2. And that's in series with R5, but they're both in parallel with 3 and 4. So this circuit and this circuit is electrically the same. And you should be now, it should be easier to translate this back into this if you look at it this way. So I just put this little thing here in an island with two little connection points here to make it not look like this. And then this, all I did here is I wrapped it around the corner. But if I put it side by side here, not changing this branch at all, here, you can tell that this is just nothing but a parallel circuit. You just have to know, you have to add those two together first. That's what that's for. And really looking ahead, because again, we don't know R1, but we know the current. So let's just not get too far ahead of ourselves. What can we do here? If you look along the columns, you see we don't have all but one, so there's not much we can do here. But if you look along the rows, I have 2 of 3 here. So I can find out what RT is. It's simply RT is VT divided by IT. So that's 3 ohms. Now, like I had mentioned in a previous video, you now have to back out because we have all of this stuff and all of this. We just don't have this. Now, all of this stuff, as I say, hasn't been calculated yet to an equivalent resistance, but the answer is found within these values that we do have. All right, so just let me bring this back in because I'm going to do it here. I'm just going to switch colors here. We know R3 is 4 ohms. R4 is 8 ohms. R2 is 4 ohms. And R5 is 4 ohms. All right, so we can add these two guys together and we get an equivalent of 8 ohms. So if you're really looking ahead here, what we have is 8 ohms in parallel with 8 ohms in parallel with 4 ohms. Now look, you can do the math. There's a bunch of different ways you can attack this because remember now this is just the equivalent of that, so don't double count that. But again, some shortcuts that I tend to teach. If you're doing this, you can do the 1 over 1 over in a parallel resistance calculation, or you can do these two in parallel with that product over sum, and then whatever that answer is, put that in parallel with this one. You'll get the same answer. But look at what we're dealing with here. 8 ohms in parallel with 8 ohms in parallel with 4 ohms. If you're looking ahead far enough, you recognize, put these two together first because they're the same. 8 ohms in parallel with 8 ohms is 4 ohms. And what do we have left? 4 ohms in parallel with this 4 ohms. We end up getting to 2 ohms. So you could do this in your head because, again, I did the numbers easily enough that you're choosing wisely. You never come out with any fractions or anything like that. This mess right here works out to 2 ohms. So if this is 2 ohms, this part here, 2 ohms, and RT is 3 ohms, by the very definition, or by the mathematics, you know this R1 has, whoops, this is a calculation, has to be 1 ohm. It has to be. This part worked out to 2. Total, we've calculated as 3. There's 1 left. All right, voltage. Well, here again, V1, I1 times R1. I know this is 4 volts. Now let's take a look here. I start out with 12 volts here. I've lost my 4 volts here. I've got 8 volts left, and it's across here. Right, so that means R3 and R4 both get 8 volts. And now, there's a couple different ways you can go here. Recognize these are both 4 ohms, a very contrived, nice circuit, which means that if this is 8 volts, this is 8 volts, I have 8 volts across these two total. They sum, but they're the same resistance. So they're simply going to split that 8 volts in half. So you know they're going to be 4 volts and 4 volts. It has to be that way. Now, if you couldn't take that leap, if you didn't take that leap, let's just work as if we don't know this yet. And I'll show you another way that you can figure that out that might be more mainstream, by the book. All right, so let's just assume we don't know what these voltages are, 2 and 5. But what can we do? We can calculate currents of 3 and 4. So what's the current calculation of 3 and 4? So 8 divided by 4, that's 2 amps. All right, what about number 4? We said we knew 8 divided by 8, that's 1 amp. Kirchhoff's current law, 4 amps coming to here. That's 4 amps, right? It's going to split. How much is coming down here? Well, I3 plus I4. 3 amps is coming down right here. What must have to be then going that way? 1 amp. So let's just say we don't know. Remember, we don't know the voltage of V2 and V5 yet. But now we've calculated 1 amp has got to be going down for I2 and I5. All right, so if you didn't know that this was going to be 4 volts and 4 volts, this one and this one, you didn't have to know that. You just used Kirchhoff's law and did the mathematics. 4 minus 3, that means 1 has to go there. You put your 1 in here. 4 times 1, sure enough, it's 4. 4 times 1, sure enough, it's 4. and 3 amps down here, I3 plus I4 better equal 3. I3 plus I4, sure enough, it equals 3. That's just a check to make sure that everything you've done is correct. So you do it multiple different ways, and then when you do it one way and you can check it the other way, it all better add up. And if it doesn't, it's a perfect example of showing you, that you've got something wrong. So start over, find out where the accident is, find out where the error is. And that is the simplicity of that one right there. Again, the hang up is you're going to have to figure out where this 4 amp goes, see if it goes in more than one spot. The other thing is just a visual mind screw. That is the equivalent of that. So redraw it without changing it. That's a bit of a trick until you get the hang of it. And then once you get it to this, it's visually more appealing. It's just visually easier to do. And that was the problem with that particular one.